Hello, and this is Mr. Marshall for Trigonometry College Year 9 Maths. We're looking at trigonometry and Pythagorean application. In this unit of trigonometry, we will be needing to read through and copy the learning intentions and success criteria into the exercise books. And then as you go through the slides, you'll need to pause, taking notes in your exercise book, and then answering the questions listed at the end of each lesson. The questions can be found in your Jacaranda Plus book along with the answers. This is week 7, lesson 5, and we're looking at composite shapes with Pythagorean theorem, or the Pythagoras Theorem. Our learning intention, we are learning to apply Pythagoras Theorem to composite shapes, and my success criteria is I am successful when I can apply Pythagoras Theorem to composite shapes and calculate the missing side lengths of composite shapes. So a little bit of revision of Pythagoras. Here's our triangle. We have our hypotenuse, which is labelled C, and we have the other two sides labelled A and B. Our general rule is C squared equals A squared plus B squared. So this is our rule for Pythagoras. We can rearrange that rule to make it a little bit more useful with A equals the square root of C squared minus B squared, B equals the square root of C squared minus A squared, and C equals the square root of A squared plus B squared. So if our unknown is this A side, we can use this first rule. If it's the B side, we can use this one. And if it is the hypotenuse, we can use this one. Now, as we are adding these two sides together, or the squared of these two sides together, it doesn't actually matter whether which side's A and which side's B. The important one is hypotenuse has to be the C side. So here's a bit of revision on composite shapes. A composite shape is made up of two or more smaller shapes. And we divide a composite shape into the smaller shapes so that we have known equations and properties that we can use for. So we can use Pythagoras to find unknown lengths, or we could use the area rules to work out the inside area. So for example, if we wanted to work out what x was on this trapezium, we can draw a vertical line from B straight down and create this point here, E. And now we've got a triangle here, and we know that this side here has to be the same as this side here, which is 10. And this side here is the remainder from there up to here, which would be 16. So here's a worked example. Calculate the value of x to 1 decimal place. So similar trapezium to before. I have my thinking side. This is what's going through my head and the steps that we're doing. And this is what I'd show my teacher how I got to that answer. So first off, I would divide the shape into smaller shapes. So I would cut it along here and create that line there. And this allows me to go, well, that's 4.2, so this has to be 4.2. And I'd work out that this here is really 5.5, that whole length, minus that 3.5, that shorter length, to leave that remainder. Next step is I substitute in Pythagoras' theorem. So that means I've got C squared equals A squared plus B squared. And when I substitute in our x for C, our 2 here for A, and our 4.2 here for B, there's our working. Then the next step is every time I'll just go through and do one change. So here I get rid of those squareds by squaring the numbers. Here I've added the two numbers together. Here I've moved a squared from here. I've square rooted to this side because the opposite of a square is a square root. And then I typed it in my calculator and I've got a number around about 4.65188. Now the question does ask to 1 decimal place. So I rounded off to 4.7 because our second decimal place here is 5, and that means we round up this 6. Does that seem right? Well, let's have a look. 4.7, we're saying that this here is 4.7. Now it's the hypotenuse, so we know it has to be more than 4.2 and more than 2. And because of the angle, it's not too steep, and this is a fairly small number. So yeah, 4.7 seems like a right number for this. You can always look at your numbers and say, does it fit what I've drawn? Okay, next work example is calculate the perpendicular height of an isosceles triangle whose equal sides are 15 millimeters long and whose third side is 18 millimeters long. And then part 2 of this question is calculate the area. So let's do part 1 now. Again, this is my thinking and this is what I would be drawing. So I would start off by drawing a triangle. Now I have to remember this is an isosceles triangle. That means two sides have equal length and one side is different. So here is my isosceles triangle, 15 millimeters, and 18 millimeters. Now, because it's a rough sketch, it doesn't have to be exactly right. It just needs to be close enough. Remember to put on the check marks here to show that this side and this side are equal lengths. Then step 2 is we divide the triangle into 2. We drop down a line from the apex all the way down and we create a right angled triangle. And because this is an isosceles triangle, the triangle on this side, the right, is the same as the triangle on the left. So it's exactly the same. That means that we've cut this line, or we've bisected this line in half. So we can just look at one of these triangles. So we've got the height, we've got 9 millimeters across the bottom because that's half of 18, and we have 15 millimeters up the side. So next step is we substitute it into Pythagoras' theorem. So c squared equals a squared plus b squared. So 15 squared equals h squared plus 9 squared. So it's a little bit trickier because the unknown isn't the hypotenuse in this case. It is one of the sides. So we've put it into there. We rearrange the equation. So again, we expand out those squareds. Then we take away 81 from this side and therefore take away 81 on that side. Gives us that, which gives us 144 equals h squared, which means we need the square root of 144, which is 12, and we need to make sure that we put in the units. Does it make sense? Does that make sense? That's 12 millimeters. Well, again, we know it's got to be smaller than this side here. So part 2 is calculate the area of the triangle. So we remember that this is 18 centimeters and we've just worked out 12 centimeters for the height. So we write the formula, area equals half base times height, and we substitute in our 18 for the base and we substitute in our 12 for our height, which is what we calculated. We do this and we calculate it to be 108, but that's not the final answer. We need to make sure we include the units. So the area of the triangle is 108 millimeters squared. Units are important. So from chapter 6.3 in Maths Quest, practice students will be working on questions 1, 3, 5 and 12. Consolidating level students will be working on 1, 3, 6 and 11. And master level students will be working on 1, 3, 11 and 15. Our reflection here is which simple shapes should you try to divide a composite shape up into? And when you're answering that, why do we want to go to those simple shapes?